Welcome to the second part of the first lecture, the Introduction into Cognitive Systems. In the last lesson, we have thought about the terms intelligence, we have analyzed the terms data, information, and knowledge, and now we will have a look at the term cognitive science. The first question is, what is cognition? Then we continue with the term cognitive psychology, which is, when you look at the time scale, the older of the two terms, and then we look at the term cognitive science. You will learn that cognitive psychology is something different than cognitive science. In the end, we will have a look at the question why should this be interesting for computer scientists. So let's start. When we look into the internet and into libraries, you will find definitions like the following. Just as a side remark, these definitions are translated from German to English. So when you look at the original sources, which I have noted below all those sites, you find the German sources. But there are English sources as well. But however, I have just for consistency used the translations of the German slides here. When we look at the book from Thiewes and Wildgrube from 1949, we have cognition as a sort of umbrella term for higher mental processes, for example, thinking, percepting, recognizing, and other mental activities. You see here, when you look at those terms, thinking, percepting, recognizing, and other mental activities, that it's not very, very precise. It's just roughly. It seems to be a difference between you think and you perceive, or you recognize. For me, it is a bit difficult to see the difference between thinking and recognizing and other mental activities, as I thought that most of the mental activities are thinking, but that's simply not true. Your brain is working on different levels, conscious and subconscious and unconscious levels, and so the cognition itself is just for the higher mental processes. When you look at the structure of the brain, you have this very, very old part, which is the so-called reptile brain, and there are other parts of the brain which are older, and the frontal cortex, which is the newest part of the brain, which is right here in front of your head. This is mainly for what we call cognition today. It's for recognition, percepting, and thinking. The reptile part of the brain, which is the oldest part of the brain regarding the evolutionary process, is for steering the life functions like breathing, heartbeat, and so forth. In the lexicon of psychology, cognition is a term for all the processes which are related with recognition and perception. So we here have it again, but they make it precisely towards a situation. They say it's about perception in a situation, recognition of the situation, judgment which you perform in a situation, the evaluation, the comprehension which you have in a situation, and the expectation you have towards the development of a situation. In another lexicon, in pedagogy, you have cognition as the ability of humans to adapt and to orient himself or herself in his or her environment. And so we have different levels of definitions, what we perceive to be cognition. Another very important psychology author duo, Zimbardo and Gehring, describe cognition as the structures and processes, so we have both, of recognition, perception, and knowledge. And here you find again the knowledge term, which we have discussed in the previous lecture. And among those are processes like processes of recognition, processes of reasoning, process of remembering, thinking, and decision-making, same as structures of the memory. Structures of the memory are, for example, short-term and long-term memory. They are also, for example, things that you can remember due to the fact that you have constructed your own memory, or things you can remember due to the fact that you have learned something and try to memorize it. The term cognition is used as a replacement of the traditional term mental or intellect. So you see here, this is really a psychology core work, this book. And they say mental or intellect is too narrowly focused and not enough for all those cognitive processes in the human brain. Let's come to a list, and let's look at a list of examples for cognitive abilities in a human being. You have here the attention, the recognition, the insight, you have reasoning, judgment, remembering, learning, abstraction, and rationality. When you look at these examples of cognitive abilities in human beings, remember we also have cognitive abilities in animals, but those are only the ones you find in human beings. Those are very, very difficult to grasp. When you try to make a definition about what judgment is, what processes in the brain are steered for judgment, it's very, very difficult. You cannot put a finger on it. You can, when you make an electroencephalogram, which is an EEG, then you can say which parts of the brain are engaged in recognition or in attention processes, but you can never say what's the result just by observing the brain when it's working. So you don't know what is the outcome. I cannot look you in the eye and see whether you're learning or not. What I can only see is the result of the learning when we make an exam. But I cannot observe learning. I cannot observe reasoning or insight. Sometimes you can see an insight in a person when somebody is saying like, whoa, I got it, now I got it. But you can only reason about insight when you see the results of a behavior. So you see, all those aspects of cognition are really difficult to observe. When you have difficulties to observe something, actually something you have invented, then it's very difficult to make a machine do exactly what you have observed. It's very difficult to put this into words. Let's look at the history. Cognitive psychology started between 1950 and 1970. There has been three main influences. The first has been research regarding stress, mental abilities and capabilities of human beings, and sad as it is, the starting point has been the training of soldiers in the Second World War. The question here has been, how fast can human beings do information processing? It's a very, very horrible example, but one of the questions has been, when there is an airplane flying over a city, how fast is the pilot able to open the gate for all the bombs you want to throw on the city, as the plane really progresses very fast. And so the point where he has to open the gates and let the bombs fall down is just a very narrow space in time. And how fast can a human being react? Still, nowadays, those questions are investigated by, for example, Department of Defense or research in military. So, sad as it is, this is a question we discuss in the ethics lecture, which is only in German. In the ethics, you have the discussion whether the things you do in computer science are appropriate and where you're allowed to do this, or whether you support war technology. The reality is cognitive psychology and psychology in general, and also computer science, is in almost all cases somehow related to, let's say, defense and military activities. However, one of those starting points has been the research regarding stress and mental abilities of human beings in the Second World War. We have had another indirect influence. This is the development in computer science. And so the research in the field of artificial intelligence. Human beings have always dreamt about the idea to construct an artificial human being. This has been in automation technology and developing of automates one of the main ideas, wow, we want to make a human being which is a sort of golem, which is an artificial human being. We want to play God, let's say it in that way. And so computer science has made advancements, and also the Second World War is one of those major steps, those major advancements in computer science. And after the computer became more and more capable of doing things, instead of only calculating, doing more calculations, more precise, more algorithms and so forth, the field of artificial intelligence began to grow. And actually this field began to grow in the 1940s, which is still the time of the Second World War, which ended in 1945. Additionally, we have another point where before cognitive psychology, the paradigm of behaviorism was the actual field of research. The main idea in behaviorism has been that you cannot look into the black box of the human being, you cannot look into the brain and see how ideas come up, but you can observe the results. So behaviorism works like, put something into the human being, or the animal, and observe the behavior coming out of this black box, as you cannot look into it. And so behaviorism has been used for insights into psychological developments, and plus psychologists wanted to be acknowledged like physicians, for example. They want to have the status of real nature science, and so they have to make empirical investigations. And to investigate learning or cognition or behavior empirically, you have to make a very clear study design where you say what is coming in and what is coming out, as you're not able to look into the system itself. This is still valid today, even if we have all those picture technologies in medicine. However, the behavioristic approaches have not been able to explain why language exists. This is very important. Human beings have the ability to use language, and language is always a structure of semantics and syntax. You always have grammatical structures, and exactly those grammatical structures are not explainable on the basis of behavioristic theorems. So the theory behaviorism has made a paradigm shift in the 1950s. One of the persons involved in this is Chomsky, which all of you might know related to the Chomsky Normalform for example, you have this in compiler construction. And this is in 1950. Chomsky, one linguist which is very close to computer science, he has said that grammatical structures develop in the human brain, and this is not explainable by behavioristic approaches. So cognitive psychology is related to a shift of paradigm from the behaviorism to the cognitive world. Cognitive psychology now has aspects of attention, remembering, learning, thinking, and language. And in the 1976, cognitive science was invented on top of cognitive psychology. And the cognitive science, actually not the cognitive psychology, but the cognitive science, integrates approaches of research from psychology, philosophy, linguistics, neuroscience, which is a medical domain, and computer science, for example, artificial intelligence. So this lecture is about cognitive science, stands on top of cognitive psychology, and started approximately 20 to 25 years after the first upcoming paradigm shift towards cognitive science or cognitive psychology. When you look at the difference between cognitive psychology and cognitive science, you have in psychology, for example, those techniques for steering experiments for investigation of human behavior, which stems from behaviorism. And these techniques are often still from the behavioristic episodes. So what I mentioned before, there's this paradigm shift from behavioristic to cognitive research. And this is cognitive psychology, and the 2 points below are computer simulation of cognitive processes, which on one hand led to more insight about human behavior, and on the other hand led to models which led to artificial intelligence. And here we have, for instance, the logical analysis as one of the major points. Let's take a step back. The cognitive psychology has developed since the 1970s regarding relevance, sufficiency, and necessity. Relevance means what is the importance of a result observed in a laboratory environment in contrast to cognition in real life. In, for example, instructional design, you always have this gap between something you observe in the laboratory situation and something you observe in everyday life. And for example, you have here the problem of the so-called observer problem. When you have an observer, you always have another result when the observer is not part of the experimental setting. For example, you can see this in physician. When a physician has to give it is called a placebo. A placebo is a medication which is not really a medication. It contains no therapeutical substance, just what's, for example, sugar or starch. And you give this instead of the real medication, and you want to see how the persons react. So sometimes when you have invented a new medication, you say, okay, we make a double-blind study, which means the physician is not able to say whether he gives this not medicine or the medicine. and the placebo is the not medicine. And if the physician himself or herself is not able to say what he gives to the patient, the placebo or the correct therapeuticum, then the results are reliable. If the physician knows that he is giving a placebo to the patient, somehow the patient feels that this is not the correct medication, and somehow then you can observe other reactions. So when you have this laboratory experiment, you have always this observer problem. The observer is part of the situation and so influences the result of the situation. When you now use a computer simulation instead of a laboratory situation, you can get into this and out of the situation of this observer problem, and then you can make an experiment with another result. Whether this is more reliable than the other result before, it's not said, but somehow you can make a more, well, let's say, reliable situation when you make a computer simulation. This is based on models, but models are another lecture. The second point is sufficiency, which means thus simple theories explain complex cognitive relations. You have here, for example, the approach ACT-R, which is a cognitive architecture, which we will look at in the end of the lecture. And theories like ACT-R are theories which try to explain how a complete cognitive system is working. Here you have the difference between very tiny cognitive processes like recognition of a string or a line of things and the recognition of a complete face. We know that a baby is able to recognize the human face very, very quickly after being born. And so there is the assumption that there must be a perception of the whole construct instead of just the perception of a line. However, the perception of the line is something which you can reconstruct very easily on the computer. The perception of the complete face is not that easily reconstructed on the cognitive model. ACT-R is a software, a cognitive architecture, which works on different level. And don't be irritated. When you look on the internet, Mr. Anderson has developed this software. He is rather old, and he has those adaptive control of thoughts theory underneath this ACT-R, and later he transformed this to advanced computer tutoring. So the abbreviation has changed over the time. No, the abbreviation stays the same, but what the meaning of this abbreviation is has changed over time. The third point is the necessity. There you need a compatibility between information processing models and insights about the underlying functionality in the human brain. Here is the approach, the cognitive neuroscience. When you look at the neurons, you have something like incoming signals and outgoing signals, and this is the information processing model. That the actual neuron in the human brain is working slightly different is another thing. So here we have an underlying functionality in the human brain, which is a mixture between electricity and chemistry. And in cognitive neuroscience, you have then an artificial model which just works with input and output on the data level or on the logical level. In cognitive neuroscience, just look at this part again. We have, let's say, three major approaches. You have this. It's just a draft of the research ideas. You have this information processing, the neural information processing. Here you have those buzzwords like neuron, you have a change of potential, you have signals, you have signal processing. And this neuronal information processing has the human underlying idea, or the not only human but also animals, how a living species is processing information via neurons. And you have a neuronal representation of information in the human brain, which says that we have continuously changing states. So we have a continuous time base and permanently shifts of states, which reflect higher and lower negativity of the membrane potential, and a variable number of neuronal impulses per second. This is the so-called impulse frequency. The underlying idea we currently have is that neurons react to certain attributes of a stimulus, and the neurons also react on sums of attribute of stimuli. So you have one stimulus or multiple stimuli, like you are cutting your finger with a knife, and this is just one stimulus, and then you have the situation around it. You're like, let's say it's a lot of blood flowing and you have bad feelings when you see blood. So then you have a sum of different stimuli in 1 second. The problem here is when you look at the neuron, you still don't know, you have no clue what exactly is happening in the human brain. You see neuronal activity. You can see this on the computer in the EEG. However, you're not able to say, for example, you see dream activity, the people are sleeping, the person is sleeping. You're not able to translate the activity of the brain to the dream experience of the person. You're not able to make, let's say, a Walt Disney movie from this dream state, as you have no idea what this neuronal impulse is doing in the brain of the human being. So this level of abstraction is comparable to not see the wood for the trees. You see the single trees, but you're not able to call this a wood. You say that somehow all those trees form a wood, but you can describe a single tree, you're not able to describe a wood in this situation. So it's a bit confusing here. Don't get irritated, it's just part of how we think here. In cognitive psychology, we currently have some problems. So it's somehow stuck. Psychologists say that part of them see another paradigm shift coming, but it's not really, nobody really knows how this will develop in the near future. There are some ideas, but this is really actual research. So current problems are here explaining simple cognitive processes is possible. So the perception of a line can be prescribed or described as a cognitive process. However, explaining a complex cognitive process is like listening to a lecture, understanding what I'm doing here. This is not yet possible. So remembering a face or remembering facts about a person is not yet possible. Take this situation when I'm now saying, think on a blue elephant. Everybody of you is thinking of a blue elephant. You can simply not avoid thinking about a blue elephant. And when I give you more details, like, wow, has it big ears or small ears? How is your blue elephant looking like? Your brain starts to work autonomously. You cannot influence this. You cannot stop this. However, your brain does even more. Related with my person and the lecture here, and it would be even more when we would have seen each other in real life, then this blue elephant is reappearing. So when you look at the slides again, without hearing my voice, and you have heard this lecture before, this will be the slide where you remember the blue elephant. And how this takes place, nobody knows yet. This is the end of this first introductory lecture. And let's now get over to the second part of the lecture. Thank you.